virtual IP load balancing with ARP sharing and floating IPs. Now that we have an active firewall cluster, we're going to configure load balancing by using virtual IPs. In this case, we're going to configure a ARP sharing virtual IP address that will be allocated in our NSI zone. So all of our clients will hit this IP as the destination gateway. So my gateway will be this IP, but then it's actually shared between firewall 1 and firewall 2. So my default gateway will be .1, but then Palo Alto 01, it's .2, and Palo Alto 02 is .3. Once I hit this IP, either 1 or 2 can take over my request and forward it upstream. This is where we take advantage of having equal traffic between the two Palo Altos, so we can take full advantage of the hardware resources by just configuring a load balancing IP, or in this case a virtual IP, and then pointing our clients to that as our last hop. We're also going to be configuring public floating IPs. Public, I call it public because this is the outside interface, and by the way, you see this is a private IP because on my lab environment I'm actually doing a NAT, so I have this IP which then goes into my public internet. So I'm just going to create a floating IP, and that floating IP will be binded to the primary unit on the cluster. We're not talking about active passive, we're talking about active active primary, which will be either PA01 or PA02, and then the secondary will be whichever has the lowest priority. We need to also configure a NAT rule. So in active, you still configure your NAT rules the same way as we were doing on our NAT section. The only difference now, we want to have a floating IP, and then we can either decide if PA01 will take our sessions or PA02. So we can bind that NAT rule to either PA01 or PA02. If PA01 goes down, that NAT flips over to PA02 because we have a floating IP pointing to either one or the other, but we can enable that floating IP to fail over in case of failure. So even though that we bind to a particular Palo Alto, if we enable failover on the floating IP object, if Palo Alto 1 goes down, it can actually float and continue working on PA02. So that's why the name floating IP. I can move it around based on the scenario. Same with the public floating IP. If I lose PA01, which is the one that is going to have floating IP as active, PA02 will get that float IP and will continue to serve requests. We're going to configure that inside virtual IP with IP ARP sharing, and we're also going to configure those two floating IPs. We'll create the NAT rules for each one, and then we're going to ping from one of my machines. We're going to use the same machine that we used on our previous video. We're going to ping the inside IP, and we're going to bounce one firewall, or we're going to suspend one firewall, and we're going to see what's going to happen from a failover standpoint, so you can see that it's very seamless. So okay, so let's go ahead and begin configuring those virtual IPs. Okay, so here on my Palo Alto, and you can see here I have my PA02 as the active primary and PA01 as my active secondary. You know what? Let's make PA01 as our active primary. You wonder how you can do that? By simply suspending this local device. So let's go ahead and do that. Click on device, high availability, operational commands, suspend local device. Press OK. Now this guy should be out of the cluster as far as traffic flow. We're going to take a look at PA01, and sure enough, my PA01 has become the primary. Okay, great. Let's go ahead and re-enable it back. Okay. Now that we re-enable PA02, now it needs to rejoin the cluster, but in this case, it will join it as a secondary unit. Now PA01 is my primary unit. While that's happening, let's go ahead and configure those virtual IPs. We'll click on device, high availability, and active config. Under packet forwarding, this is where we enable that HA3 interface. We're going to configure virtual addresses, and this is where the virtual IPs are going to be configured. Let's click on add, and let's add the first one. Add that inside IP, which is the load balance ARP sharing address. This is going to be the 10.0.0.1. Let's take a look again at the diagram. This is going to be this virtual IP. This is going to be IP ARP sharing, and we're going to enable this between the two firewalls. Going to click on Add Interface. This is where the actual physical interface of that virtual IP will sit in. In this case, it's the inside, which is 1/2. We'll click add, and we're going to add that IP. So we have 10.0.0.1. Now we're going to select either floating or ARP load sharing. We want to load balance that between the two firewalls, so we're going to select ARP load sharing. And it's telling me what kind of load balancing algorithm we're going to select. We're just going to do IP modulo, which is the recommended Palo Alto way of doing this. So we're going to select IP modulo. We're going to click OK. And sure enough, now we have that virtual IP created. And if you can see here, we can also have it as a floating, so we can convert this into floating by binding it to the active primary. So in this case, all traffic will hit just PA01. If PA01 goes down, it will flow to PA02. In this case, we're just going to leave it without active primary, so we want to take advantage of sending the traffic to both units. We'll press OK. Now we have that virtual IP created. Let's go ahead and commit, and let's see. By the way, before we commit, take a look at my machine. We're going to ping, and sure enough, obviously it's not responding. However, what if I ping my local member? There you go. This is PA01. I am able to hit the physical inside interface of PA01, which is 10.0.0.2. Okay, and this is a PA02, which has the internal IP of 10.0.0.3. So I know that I'm able to hit both firewalls. Now I just need to hit that new load balance IP, and then we're going to leave this running, and then we're going to make the change. Okay, let's go ahead and click commit. Press OK. Okay, it has finished. So let's take a look at the computer again. There you go. Now we have our virtual IP, and this virtual IP is active on both PA01 and PA02. Now my clients will point to this IP as the last resource. In case PA01 goes down, they're not going to notice because we have load balancing between the two units. You can see here, for 1 second, we lost 2 pings. The reason why is the configuration from PA01 was being synced. PA02. So now PA02 also has the same object, so that's why you saw that brief interruption here. But this is actually a good sign. Then that means that both firewalls are currently active. Okay, let's go ahead and configure those floating IPs now. Let's begin with the public IP. We want to do a floating IP, and we want to bind that to both firewalls, but only one will be active. Select the outside interface 1/1. We'll click add, and now we're going to type this new IP, which is going to be 10.10.20.121. In this case, we can either do floating or ARP load sharing. In this case, I'm going to do it at floating so you can see the difference between one and the other. And then I can select to be bounded to the active primary device by clicking here, or I can actually have some sort of load balancing, meaning that I have more priority in device 0, which you remember during the HA configs, device 0 was allocated into PA01, device 1 was allocated to PA02. So I can either have more priority of one or the other, or I can just have an active primary device. In this case, the address will be assigned to PA01. If PA01 goes down, it will be assigned to PA02. And you can see here, right at the end, you can see failover address if linked state is down, and that's what we talked about. The address will move between the firewalls in case the active primary goes down. So it's going to float over to PA02. We want to leave this checked, and we're also going to assign this to the active primary device. We'll press OK. And now we have that. Finally, we're going to configure that other floating IP, and this will be used for that NAT rule. Let me show you back. Our diagram, we also have a destination NAT. So we have a web server, and we have a couple of public IPs. We want to allocate a public IP to this particular web server by using a floating IP. So we are going to create this floating VIP. If someone from the outside hits the address, will be sent to the web server. The NAT configuration will be the same. If you're still unfamiliar with how to configure a destination NAT, I'll suggest you go back onto the destination NAT video and you take a look at that and you become familiar. So I'm going to go ahead and do that config. The only difference in this case will be that we're just configuring that floating IP. Okay? Now that we need to configure that destination NAT, it's also a public IP, so it means that needs to be binded again to the same outside interface. So we're going to click the existing outside interface that we configure the public IP. We're going to add that new one. Okay, so we have a 10.10.20.200, and we're going to make it floating as well, and we're going to bind it to the primary device. Press OK, OK, and boom. Let's go ahead and click commit. Once that's done, you can either commit now or you can create the NAT rule and then commit. Let's go ahead and create a NAT rule after this commit. Let's go ahead into policies, NAT. Let's click on add, and let's create the first rule, which is going to be the first load balancing IP for our internal users. In order for them to go outside, they're going to use the 121 address. Let me show you again. They're going to be using this public IP, so we need to do NAT translation. Okay, inside to outside, original packet, source, inside, destination, outside, destination interface, Ethernet 1/1, translated packet, and this is where the magic happens. Translation type. We want to select IP import because we're basically doing a pad and we need to the outside to the internet. We want to select IP import. Address type. This case, we can select either translated address or interface address. Because we're using a floating IP, we can use a translated address, add the floating IP, and then configure the same thing on PA02. So let me go ahead and do that. Translated address, in this case, will be, okay? And the most important item here, active HA binding of this NAT rule. Where do we want to bind this rule to be effective? We have two firewalls, 0 and 1. 0 meaning the configuration device ID is 0 for PA01 and 1 for PA02. In this case, we're going to make 1 for PA01, and then we'll make another one the same for PA02, and we should be good to go. So we have the first one, and you know what? Let's do the same thing for the second one, but let's just use the clone function, and we'll say we're going to move it on the bottom, and boom. So we have the same rule. The only difference that we have to do now is change the active HA binding. Okay, so once we open their NAT rule, active HA binding, in this case will be 1. And now we have both rules. This rule for PA01, this rule for PA02. If PA01 goes down, I still have the same rule for PA02, so I should be good to go. Okay, let's go ahead and configure that destination NAT. Okay, original packet will be coming from the outside, going to the inside. Destination interface will be 1, 2, which is my inside interface. Source address is coming from the outside, so it can be any destination. This case will be my public floating IP. Okay, 200, and now translated, I am going to point to the real IP. 10.0.0.200 is my internal web server. So that's the NAT rule. 20.200 as my outside NAT address, going to the private address of 10.0.0.200. Okay, and I have this here, and finally my first binding will be to PA01. Okay, let's go ahead and duplicate it. Let's clone it here, let's put it below, press OK, and now we just need to change the binding. Okay, in this case it's just going to be 1, everything else stays the same. We'll press commit, and we should be good to go. Once that's done, we're going to do a failover test by pinging 10.0.0.1, and we'll see how that looks like from a failover standpoint. So we're finished here. Okay, so now we have created NAT rules using floating IPs. So we have our inside to outside NAT. So in this case, imagine if this was a public IP. Now we have a floating public IP from PA01. If it goes down, we can still use it on PA02 because we have enabled under the virtual IP settings, we enable failover if this primary unit goes down. So if PA01 goes down, I still have the rule for PA02, so I should be good to go. So this rule applies to PA01, this rule applies to PA02, and we should be good to go. Same here. This one will apply to 1, this one will apply to 2, and same way. If one goes down, the other one should still flow traffic. Okay, so from the failover standpoint, in an active, it should be even more seamless because we have a load balancing between the two firewalls. We're pointing to a virtual IP. Either one of them goes down, the virtual IP will still remain the same. It will still be binded to both units. It's just one will not be able to forward request. So let's go ahead and do that. And first of all, I'm going to check my machine. We're pinging from my internal network to this load balancing IP. We're just going to suspend one of the units, and we'll see what will happen to this virtual IP. Okay, let's go ahead and disable PA01, and we're going to suspend this local device. Press OK, and this guy is completely out. and PaO2 just became the active primary. Let's take a look at the machine now. And there you go. Just one ping. After that, boom, we're back in action. Nothing really happened. Just one single ping, and nothing happened. Everything is working, everything is operating, and you can continue sleeping at night. So you're not gonna face a failure scenario where you have a firewall that just went down and nothing recovered. If you implement a true HA environment where you have both firewalls acting as a cluster member, or one even active standby. If you have active standby, all that matters is that you have redundancy. You have some way of maintaining connectivity. If you lose one firewall, if it goes down, something as simple as upgrading the firmware. What happens if for some reason you upgrade the firmware or something, it doesn't go according to plan, the firewall is shut, the firewall died, the firewall can't boot, 2 a.m. in the morning, you're remote, no one is in the data center to help you. Well, trust me, a standby firewall will definitely save your day and your week. So make sure that environments are critical. Make sure that there's redundancy, N+1 everywhere. We want to make sure that all firewalls or like critical devices such as firewalls, they need to be highly available. So you want to make sure that you have both units active or active standby. Alrighty, and that's it. That's active standby and active. Okay, everyone, in our next video, we're going to take a look at virtual systems. Thank you for watching.